All right, good morning. Today we are going to be comparing linear, quadratic, and exponential functions. And the last IXL is probably the hardest. That's where you have to come and you're given a table or given some information and you have to write the linear function, the quadratic function, or the exponential function. Now, linear should be pretty easy for us, so I'm not going to cover one of those. Right? Linear is for every one x value, we're going up by a consistent y value by twos, by threes, and that's our slope. But sometimes it's hard to identify the difference between a quadratic and an exponential function when given in a table. So we're going to talk about how we can write these. First, we need to identify how something is changing. So for this first problem, we are going up by ones on our x value. We still need to identify this because sometimes I try to pull a quick one on you and they go up by a different x value instead of by ones. So be careful. How are our y's changing? And that really tells us if it's a quadratic or if it's exponential. Here, from 4 to 16, right, we could say we're multiplying by 4, but we're going up 12. From here to here, we went up 20. And from here to here, we went up 28. Okay. Now, the reason why I went by addition is because 4 times 4 is 16, but 16 times 4 is not 36. So I don't have that common ratio. Okay. And that's what exponentials look like. For quadratics, we don't have a consistent change here. However, the second, and this kind of talks a little bit about it on the key concepts, the second change is consistent. We're going up by 8 each time, so this is going to be quadratic. Now we have to write the quadratic function for this. Now, what can help us is to find the zero, right? But we know one thing, we know that the x, one of our points is 1 comma 4, one of the points is 2 comma 16. If we go back to 0, we would get 0, so our y-intercept is 0. So we know that we are going to have a c value of 0, and we end up with 4x squared. There's our answer for our quadratic. For our exponential function, we're going up by ones for our x value, and as we're going up by ones, we have a common ratio. We are multiplying by 3. We are multiplying by 3. That does not happen in the quadratic. We have a common ratio. We're multiplying by 3 each time. When we write exponential functions, we know that our base is our common ratio. Our exponent is going to be our variable of x, and our a value is our initial value, which is when x is equal to 0. X is equal to 0, it is -3, so my y value, or my a value here is -3, so my function is y equals -3 times 3 raised to the x power. So that's the difference between quadratics and exponentials when we look at a table.